All right, I'll be going over how to identify a chiral center is RS and how to use it to identify enantiomers versus diastereomers. So pretty much the definition of chiral is something that's not identical to its mirror image. And if you want to find a chiral center, you just look for an atom that has four different bonding environments or four different things it's bonded to. So in this case, here's an example of this carbon is a chiral center because it's bonded to four different things. That's four different bonding environments. And the first step to identify if a chiral center is RS is you need to do priorities. You need to make priorities. So I made a video about E or Z compounds and how to identify priorities. So if you don't know how to do that, go to that video. But so pretty much it's you look at which is the heavier element and you assign that a higher priority compared to the other ones. And to view if something's RS, you put the smallest group in the back. Usually it'll be an H. And what you do is you want to count from the highest priority to the lowest priority and see which direction it goes. So if you count 1, 2, 3 and it's going clockwise, then it's a R. But if it goes 1, 2, 3 and it's going counterclockwise, then it's an S compound. So in this example, you see the OH is 1, then 2 is the ethyl group, and the 3 is the methyl group. So if you go in the circle, you see it's going to be going in the clockwise direction, so it's going to be R. So here, like I showed before, see how the OH, the ethyl group, and the methyl group is going to be R. When the H is, and we got to make sure, the biggest thing is you got to make sure that H is back. If the H isn't going to be the atom that's wedged, it's not going to work. So yeah, put the lowest group in the back. Same example here, it's going counterclockwise, so that's going to be S. And here, if the lowest group is in front, then you have to do then pretty much what you see is it's the opposite. So here it looks like it's S, but since the lowest group is in the front, you reverse it. So this would really be an R. Yeah. All right, so here's some examples. So here, if the lowest group isn't in the back, then you got to kind of maneuver it to where, like if it's on the side, then you got to kind of maneuver it like in your head. A lot of times using some sort of like kit molecular modeling kit would help. So in this case, we got, if you maneuver this compound to where you put the H in the back, you'll realize that the Cl is that it's going to form a R compound. Here, it's here the H is in the back, so we could just count normally. So here's the first priority, here's the second priority, and here's the third priority. So that's going to be R. Here, this would be the first priority, this would be the second priority, here's the third priority, and it looks like it'd be S, but since the H is in the front, you just reverse it, and then it's going to be R. And there's some more examples if you would like to go through them. Okay, so now that we know that, how do we use this? So in an enantiomer, all the chiral centers are going to change. They're going to go from R to S. If two compounds are enantiomers, one's going to go R to S. All the chiral centers are going to go from either R to S or S to R. Where in diastereomers, only one of them is going to change. or not all of them will change. So let's say you have an atom with two chiral centers, they're both R, and then in the other atom, they're all the atoms are bonded to the same things, but one is R and one is S. That'll be a diastereomer, not an enantiomer. So for an enantiomer, all the stereoisomers need to have opposite configurations. So if you look here, these two are enantiomers because the 2 carbon and the 3 carbon here are both S, where over here there are. But if you look down or across, only one of the, oh, well, this is blocked, but only one of the chiral centers changes. So these are diastereomers, where over here they're enantiomers. And yeah, that's how you decide whether a chiral center is RS and whether they're diastereomers or enantiomers.